Hi everyone, welcome to Chapter 5. We're going to divide Chapter 5 up into a couple of different videos. This will be Chapter 5 Part 1, which we're going to discuss random variables. The book does a fantastic job of discussing random variables, talking about how to solve the problems, and gets into great detail there. I highly recommend you spend some time with it. What I'm going to do is show you how to do a sample problem that's very similar to the sample problem in the book on roulette, and is also very similar to one of your homework problems. I'm going to go through the process of inputting the data into Excel and solving it through Excel. The problem we're actually going to be doing is number 25 in that section, and that is going to cover the Illinois lottery. You're going to find a lot of lottery questions when it comes to probability because that's something everyone can relate to, and it's one of the few real-life situations where probability is needed and something with which everyone has been exposed. Gambling problems in general, you're going to find a lot in probability. So let's go ahead and start on this problem. I'll read you the problem quickly. Finding expected value for the Illinois Pick 3 game. In the Illinois Pick 3 lottery game, you pay 50 cents to select a sequence of 3 digits, such as 2, 3, 3. If you select the same sequence of 3 digits that are drawn, you win and collect $250. Now the question is divided up into A through E. First question, how many different selections are possible? So we're going to go Chapter 5, problem 25. I'm going to start with A. Well, if we have 3 options, the easiest way to do this is going to simply, we're going to have to take something to the power of 3, the number of options to the power of 3. And I believe we discussed, well, we didn't discuss it, but the book discussed it in the last chapter. So for each number, there are 10 options, 0 through 9. So you're going to have 10 to the power of 3. 10 options, 3 digits. 10 to the power of 3. I need an equal sign there. 10, and for those that don't know in Excel, on my keyboard it is Shift 6. You get the little arrow thing up there, and 3, so that's 10 to the power of 3. That's how you do powers in Excel. And we're going, and I believe 6 is a universal key for that. Hit enter, and the answer is 1,000. So that means there are 1,000 different selections possible. So what's the probability of winning? At this point, we should all know that and not have to do any math and other than what's obvious to us. 1 in 1,000. So if there's 1,000 options, the odds of winning, 1 in 1,000. Okay, C. If you win, what is your net profit? Well, they tell us that if we win, we collect $250. Collect $250, but we have to subtract what we paid to make the bet. So we have to subtract 0.5 for 50 cents. So $249.50. These are the sections of the problem that aren't too difficult. Now we're going to get into something a little more complicated. Letter D. Find the expected value. And this is something you could apply to any gambling situation. Not that all of you are out gambling all the time, but this is typically where this type of problem is applied. And this is how the odds in gambling situations are calculated. They do expected value. So we're going to do expected value like they do in the text, which is a good way to do it. We're going to set up several columns here. We're going to have X, probability of X, and X times the probability of X. And what goes where will make a little more sense in just a second. First, we're going to calculate how much we're going to lose based on probability, the amount we're going to gain based on probability, and the total. So the amount that we would lose would be our bet, so that would be a negative number, and the number is 0.5. So the probability of losing our bet is what we're going to calculate. Now we know the probability of losing that bet is, we're going to lose it 999 times out of 1,000. I forgot my equal sign again. back and put that in there. So the probability of losing 50 cents is we're going to lose that 50 cents 999 times out of 1,000. Okay? And then we're going to multiply the odds of losing the bet times the amount of the bet. So we're just going to do an equal sign. We're going to select that cell, hit the multiplication sign, then select that cell. So we're going to multiply those two cells together. All right. And there we have it. Now we have to multiply the amount we expect to gain. Well, the total amount we would gain is the net profit. So that would be from problem C. So we have to take the amount we would win, which is $250, and subtract the 50 cents. So it would be 249.5. And then the probability of winning that is equals 1 divided by 1,000, or B. All right, then we multiply those two together. I'm just going to drag the formula down from that cell. It'll do it for us. And then we're going to sum these two cells to get our answer. The expected value of playing in the Illinois Pick 3 lottery game is, it's expected you will lose 25 cents. So the state has the advantage, which of course everyone knows. But the expected value, mathematical value, is negative 0.25. Now question E. Says, if you bet 50 cents in the Illinois Pick 4 game, the expected value is negative 25 cents. Which bet is better, a 50-cent bet in the Illinois Pick 3 game or a 50-cent bet in the Illinois Pick 4 game? The result is the same, negative 0.25, so it really doesn't matter which you would play. You could expect to lose the same amount. All right, that's it for part 1 in chapter 5. We'll see you for part 2.